Hello everyone. Today we're going to be going over general form. So it's just a different way to express a equation of a line. So we've looked at two already. You may want to just pause the video and see if you can remember them. But they're also on the video or on the formula sheet. So first one we covered was mx plus b. The name of that is slope-intercept form. So slope-intercept. The m is the slope, the b gives us which intercept? The y-intercept. And we also did slope point form. So that looks like that. Again, this is on your formula sheet, so no worries there. The name for that is slope point form. Okay, so categorizing each of these four equations here, this would be slope-intercept, this would be slope-intercept as well, this is slope point, and that's also slope point. So there's four common ways in which the equations of a line can be expressed. Y equals mx plus b, we've done that, that's slope y-intercept. Slope point is that one. And two we're going to look at today, well, mainly general form, but standard and general form, both good. So the conditions on these is a, b, and c need to be integers, so that's like -3, -2, -1, 0, 1, 2, 3, so on. So basically all the whole numbers, including their negatives. That's what we need, and we need another condition met, the a, so the coefficient with the x has to be positive. So x coefficient must be positive as well. So that's what that condition means. Maybe. So that x coefficient must be positive. Okay, so let's have a look at these four here. You might want to just try these out on your own first, but we'll go over them in a second. Okay, so this first one is we've got coefficients, so it looks to be standard. If it was 3x minus 5y plus 10 equals 0, then it would be general. Okay, this one we've got stuff with the y, there's a fraction in here, there's stuff in brackets, that's slope point. Slope point. This one, y is on its own, there's nothing in brackets. Yeah, so that'll be y-intercept, slope-intercept. And this last one would be general because it's got a positive coefficient on x, everything's an integer, and it's equal to 0. So that is general. Okay, so general and standard form are very similar. The focus today will be on general form. So note all the coefficients in general and standard form must be integers. That's an important requirement. And so the equation cannot have any decimals or fractions, so don't have those. Coefficient of x must also be positive. Okay, alright, so we have a few line equations down here, and we're going to convert them to general form. So this first one, 5x 6y equals 6y minus 7. So in order to get it into general form, I need to just equal it to 0. So maybe don't write this yet. I think probably the easiest way for me to accomplish getting that equal to 0 is by subtracting 5x from both sides. So I'm going to have this. So hopefully you didn't write that yet. Is there any issues with this? Does that look to be general form? So we've got something x plus something y plus some number. It's equal to 0, so that's great. But I have one thing that's wrong here. The coefficient of x must be positive. So this here is an issue. So that needs to be fixed. So rather than, bringing everything to the right, instead what I should do, so I guess if you want to just maybe not write that at all, that would probably be not a bad choice, but I'm just going to leave it so you know what to avoid, right? That's an issue. So rather than do that, I bring the 6y and the negative 7 to the left. So I would have 5x, maybe I'll just write that in a different color pen. So 5x minus 6y plus 7 equals 0. That would be correct. It's because it's got a positive x coefficient. Everything's an integer. It's equal to 0. Good to go. Okay, on to the next one. We've got something in slope-intercept form. I got to get rid of the fraction here. So quickest way I can get rid of the fraction, I get rid of the 3 in the denominator, is I'm going to multiply everything by 3. So I'm going to multiply the left side by 3 and the right side by 3, so 3 times y, and 3 needs to hit each of these terms in the brackets. So 3 times y is just 3y. Negative 2/3 times 3, so negative 2/3 times 3, or 3 over 1 if you prefer, be negative 6 over 3, which is negative 2. So the numerator gets kept. So negative 2x plus 3 times 6, 18. I need the coefficient on x to be positive, so I can't just leave it on the right side here. I should bring it to the right, or to the left. So I can add 2x to both sides. So add 2x, and I also need to add 18. Nope, fix that. Subtract 18. So I'm doing that with both sides. So that will give me ultimately 2x plus 3y minus 18 equals 0. Right? So, yeah. Okay, moving on. I need everything to be an integer, so it would be helpful to get rid of that 5, so let's do that. So multiply both the left and the right by 5, keeping in mind that needs to hit each term. So 5 times negative 6/5 will just be negative 6x. 5 times positive 4y will be 20y. 5 times negative 2, negative 10. Okay, that's equal to 0. I obviously need that to be a positive integer, so it currently isn't. So if you like, you can think of bringing everything to the right side, or you can divide everything by a negative 1, or if you prefer, you can multiply everything by negative 1. Ultimately what happens is just the signs of each of these flips. So I would get 6x minus 20y plus 10 equals 0. That's done. Okay, and then, so again, this fraction problem, I got to get rid of the fraction. So if I multiply both sides of this by 2, that gets rid of the denominator on the right. So keep in mind, I need to multiply each of those, and then maybe it might be easier. So I'll just maybe distribute this 7/2 first. So it might be easier just to think of 7/2 x plus 21 half. So 7 times 3, 21. 2 times 1 on the bottom is 2. Okay, and then, alright, so now I think it'll be a little bit more intuitive to see that if I multiply both sides of this by 2, it gets rid of the fractions on the left, sorry, on the right. So that'll be 2y minus 10 equals 7x plus 21. I need to keep the x on the right side, so I need to bring these ones over to the right. So I can do that by adding 10 to both sides and subtracting 2y on both sides. Right, 2y minus itself is 0, and 10 minus 10 will be 0, so we got 0 equals 7x minus 2y plus 31. Okay, moving on. Line passes through 3, -5 with a slope of 4/5. Determine the equation of the line and express it in slope point, slope y-intercept, and general form. So slope point works great for us in this situation because we have a point. It is not a special point, it's not B, right? So it's not, we can't use this one right out of the box because this is just a random point. We have the slope though, so that's M. So given a point, a random point, and the slope, we use slope point form. So that would be my first choice anyways. So I guess it's helpful that that's what they want first. So subtract y1, so subtract -5 equals m, which is 4/5. And then x subtract 3. Subtract 3. So that'll give me y plus 5 on the left. 4/5 x minus 3. Okay, and we can just leave it at that. So that's slope point form. If I want to take that into slope y-intercept form, I just need to get y on its own. So from here, I would subtract 5 from both sides. Giving me 4/5 x minus 3 subtract 5. So it might be helpful for me to distribute this into each thing there. So that would be y equals 4/5 x minus 12/5. Now if I'm going to be subtracting 5 from this, it would be helpful to have a common denominator. So -5 would be equivalent to -25 over 5. Right, so now they have the same denominator. -12 subtract 25 will be -37. This is, okay, so y equals 4/5 x minus 37/5. So that is, hopefully you got a little more space than I do here. Okay, moving on to general form. So if I want to get this into general form, I should get rid of the fractions, so the denominators. If I start by multiplying both sides, I'll just write it out. What can I multiply both sides of this by to get rid of the 5 in the denominator? So I should multiply both sides by 5 over 1 if you prefer. So 5 times y is 5y. 5 times each of those things. We'll get rid of the 5 in the denominator, so we have 5y equals 4x minus 37. Keep the x on the right because it's already a positive coefficient, so I need to bring this y to the right. So 0 equals 4x minus 5y minus 37. guess if we wanted to get really specific, I guess we should have this all on the left so that it matches up, but it's pretty minor. Okay, and then last into standard form, so we'll start with 4x minus 5y minus 37 equals 0. I just need to bring this thing to the right. So I add 37 to both sides, giving me 4x minus 5y equals positive 37. So each of these are integers, coefficient on x is positive, good to go. Okay, and state the equation of the line shown in general form. So here we have a special point. This is the Y-intercept, so that's 0, 2. I can also determine the slope from here. So going from there to, looks like we go through the crosshairs there, down 1, right 3. So slope is rise over run, negative 1 over 3. So I can take this information and put it into slope-intercept form. So mx plus b. So negative 1/3 x plus 2, right? Because that's b. And then we got to get it into general form, so I need to get rid of this denominator. So a quick way to do that, I can multiply both sides by what? 3. So then we get 3y on the left equals 3 times negative 1/3 is just negative 1, negative x. 3 times 2 is 6. I need this to be positive, so I should bring all of this stuff to the left side. So I add x to both sides, x plus 3y, and I need to subtract 6 from both sides. Subtract 6 equals 0. That's general form. So it's 1x plus 3y minus 6. My condition that a is greater than 0 is met. So that's it. Okay, moving on to the next page. Determining the x and y intercepts. So, in order to graph a line, you either need 1 point and the slope, or 2 points. So, for lines in the equation mx plus b, you know the slope and the y-intercept. Okay, and for lines given in the equation of slope point form, you know the slope and a random point, not a special point like the y-intercept, just any old point. Okay, if you are given the equation of a line in general form, so like this, do you know the slope or any points? So what we can do is generate a table to find some points to plot. The two most common points to use to determine to graph a line are the intercepts. Seems a bit weird. Okay, if you recall, the x-intercept is where the line crosses the x-axis. So, for example, that's the x-intercept. Okay, so put a box around the x-intercept. That's that one, right? What are the coordinates? So what is the y value when the graph crosses the x-axis? It's 0. So it'll be x comma 0. So question to ask yourself, what is the y value when the graph crosses the x-axis? So that is a helpful question to ask yourself. In order to find the x-intercept, you substitute 0 for the y variable. Okay, moving on. So the y-intercept is where the graph crosses through the y-axis. So that's the y-intercept. Put a star around it, so that's the y-intercept. What's the coordinates for any y-intercept? Well, it'll be 0, y. So question, I guess, that corresponds to this one, what is the x value when the graph crosses the y-axis? So in order to find the y-intercept, you just substitute 0 in for the x variable. Alright, so here we have an equation in general form, x plus y minus 5 equals 0. We're trying to graph it. So when the equation is written in this form, the slope or any points on the line are not as obvious like the other two forms we've looked at. So we can generate points using the equation. Remember, you need 2 points, and we're needing to algebraically determine the intercepts and then graph the line. So that's what we're going to do. Algebraically determine the intercepts and then graph the line. So let's start with the X-intercept. Again, what's the y value here? Y is 0. So we go x plus 0 minus 5 equals 0. So we have x minus 5 equals 0, and solving for x equals positive 5. So the x-intercept will be here. Now for the y-intercept, question to ask ourselves is, what's the value of x here? So the value of x is 0 at the y-intercept. So starting with the equation up here, I just put a 0 in where x happens. So we have y minus 5 equals 0. Solving for y, we get y equals 5. So that would be 0, 5. I'll just put that point down. And so this one from earlier, when y is 0, x is 5. So 5, 0, that's where that one went. So now we can draw the line. Try to get those kind of parallel. And, not quite. Alright, so that's the line. And we did it. Graph the line. There it is, graphed. Okay, next we're going to sketch the graph of this one using intercepts. So same procedure. Let's start with the X-intercept. What's the value of y here? Oops, that's not a 3. 6x minus 3 times 0 plus 12 equals 0. So 6x, this is just 0, plus 12 equals 0. So we get 6x equals minus 12, right? Subtract 12 from both sides. Divide 6 both sides. X is equal to negative 2. So negative 2, 0 is where the x-intercept happens. And now we can move on to the y-intercept. Y-intercept. What's the value of x here? So 0. 3y plus 12 equals 0. 6 times 0 is 0. Minus 3y plus 12. Okay, I need to get the y's on their own to one side. So what we can do is maybe add 3y to both sides. We get 12 equals 3y. and then get rid of the 3. 3 times y, the opposite of multiplying by 3 is dividing by 3, so we get 4 equals y. 12 divided by 3 is 4. So the y-intercept will be 0, 4, which is there. And now we have 2 points. Now we can draw it. So let's go ahead and do that. Good enough. Hopefully you can draw it a little more precisely. I think I can do better. Let's see. Just line that up a little bit better. So hopefully you can do that a little more precisely on your own paper. Okay. I'm going to get you to do the following questions. I'll get you to do this. Sketch the graph, so you have something this time in standard form. Process is the same though. Get your x and your y-intercept. You'll get 2 points from that, and then you can put those 2 points on the grid here and connect the dots. Okay, and I'm also going to get you to do this one. So algebraically determine the x-intercept of this line as an exact value. So you should have at the end of this question some number, comma, 0, right? Because what's the value of y here? So y equals something. Oh, y equals what here? So there's your hint for that one. You should end up with an exact value, so not like 2.117 repeating or something like that. When it says exact value, it should be in a fraction form or integer. Okay, so in summary, given a line in general form, the x and y intercepts can be found by substituting 0 in for x and y, and solving for the remaining variable. When we found the x and y intercepts, we can determine the slope of the line. And the slope is positive if the intercepts have opposite signs. So I'll show you what that looks like. So we have x, y, x, y. So maybe I'll do just kind of opposite signs. So for example, if the x-axis, or sorry, the x-intercept was negative, the y-intercept is positive. So you can see if you connected those 2 points, that would be a positive slope. And different if the x was a positive intercept. If x is positive, y is negative, so that's an opposite sign. And you can see if I connected those 2 points, that would be a positive slope as well. Okay, and if we have, let's do that. So negative if the intercepts have the same signs. So for example, let's draw another figure here. There's x, there's y, x, y. Same signs, so positive x-intercept, positive y-intercept. If I connected those two, we have a negative slope. And if I've got a negative x-intercept, I have a negative y-intercept. That's a negative slope as well. Okay, so yeah, I would like for you to just send these in to me, and also try some questions with the practice today in your textbook, page 384, number 5 to 9, 15, 18, 21 to 24, 27, and the pizzazz. 150. So that's it for me for today. See you next time.